Hi Bacho, welcome back to my channel. With me, I'm your mystery teacher, and today we're going to study about Newton's first law of motion, which is also known as the law of inertia. In the last class, we discussed what inertia is, what are the different types of inertia. You could see it in the video that I have, the link of the video that I've shared in the description as well. And then we're going to take it forward here and discuss about the first law of motion and also understand why is it called the law of inertia. Fine. Now, just to have a quick recap, what is inertia? We discussed inertia is nothing but the tendency of the body. It's not a force. Remember, I emphasized it in the last video as well. It's the tendency of a body to resist any change to its state of rest or motion. I hope you remember. Inertia is nothing but the tendency of a body to resist any change to its state of rest or of motion. By that, what it means is, if any body which has some mass, for example, let's say a book or a glass which is kept on the table, right? So that glass will have the tendency to be at rest. If it is at rest originally, it will continue to be at rest unless you apply an external force and you pick it up and you keep it somewhere else, right? Or right now, if you're sitting on your chair and watching this video, or you're lying down on your bed and watching this video, so you will continue to be lying down or you'll continue to be seated unless you apply additional force and get up and then move and change your position, right? From rest you come to motion. So that is inertia. Every body that has mass has inertia. Okay, now the Newton's first law of motion deals with inertia. It talks about inertia at length, and it says that every body normally has inertia, right? And that inertia is changed only and only when an external force is applied to it. Let's understand the law. Now see, what does the law say? It's the tendency of any object at rest or in uniform motion to continue being at rest or in a state of motion unless an external force is applied to it. Now see, if you see till here, it is nothing but the definition of inertia. The tendency of any body which is at rest to continue being at rest, or the body which is in uniform motion to continue being in motion, is inertia. It says that the body will keep exhibiting inertia unless an external force is applied to it. Let's understand with an example. Suppose you are on a playground. This is a football, right? And you're standing here. Now, unless and until, and we are assuming that it's not a windy day, there are no other factors that could move this football on its own. Now, unless and until you kick the football. By that I mean you apply external pressure on this football. Can you think of any scenario by which this ball can move? And I'm saying, please don't think of those extraordinary situations where it's super windy and the wind will move the ball. No, even when the wind moves the ball, the wind is applying external pressure. Remember, I'm saying when no external pressure is getting applied on the ball, no external force is being applied on the ball. Can you think of a scenario where this ball will start rolling or start moving on its own? No. Why? Because this ball is exhibiting inertia of rest. Remember, in the previous video we've discussed the three different types of inertia, which is inertia of rest, inertia of motion, inertia of direction. If you have forgotten, quickly go watch the video. You'll find the link in the description and quickly revise those concepts. They are very important, right? So coming back, this ball will not move on its own because it is exhibiting inertia of rest. You can only change it if you come and kick the ball. You apply an external force to the ball. Now the ball will start moving, right? And that is what is your first law of motion. Please remember very clearly, the wordings of it seems like it's very written in a convoluted manner. It's very simple. It says tendency of any object to remain at rest or to remain in uniform motion unless an external force is applied to it. Okay? Fine. Let's look at few real life examples of Newton's first law of motion, and there are millions and millions of examples that you'll find happening around you. If you start observing, you'll realize it yourself. Now, if any of you play carom, see a pile of carom coins that are stacked when you just start the game. They remain intact when the lowest coin in the pile is struck quickly by the striker. Why does that happen? Because the caroms, the coins that are stacked, they are at rest, so they will have the tendency to remain at rest, right? Now when you apply external force only to the lowest coin, only to the lowest coin, right, what happens? This coin moves, but the remaining coins, they continue to be at rest, so they are exhibiting inertia of rest, right? And the lowest coin that moves, this proves my first law, which says that this coin would have continued to be at rest unless you apply an external force and move it. Okay? Second example is when a bus or a train starts suddenly, the passengers standing inside it fall backwards. Now why is that? Suppose this is the floor, this is the bus, this is the floor of the bus, you are standing here. Now when the bus starts moving suddenly, what happens? Your upper body is still at rest, so it wants to continue being at rest. Your lower body or your feet, which is in contact with the bus, the floor of the bus, that starts to move, right? So this is moving forward, but your body is at rest, so it wants to continue being in the same position, and that's why you tend to fall backwards. Understood? Like I said, if your body is at rest, it will continue to be at rest unless an external force is applied to it. Again, another example, when a tree is vigorously shaken, some of the leaves fall down. Why? Same logic. The branches of the tree come into motion, but the leaves continue to be at rest, right? So the external force that you are applying to the branches, so they change their state and they come to motion. Trees continue to be at rest, and that's why they tend to fall down, right? Another example, and again you must have noticed it, jumping out of a moving train. When people jump out of a moving train, you must have realized, if you've ever seen, that they run along with the train for a little bit and then they let go and they come to a stop. Why? Because if they jumped and they suddenly come to a stop, what will happen? They were moving with a train at a particular speed, the speed with which the train was moving. If they quickly jump and stop, their body will come in contact with the ground, and the ground is at rest, right? Now suddenly from 80 kilometers per hour, they are going to come to rest, which is 0 kilometers per hour. What will happen? They'll stop with a great thud, and there is a chance of them injuring themselves. So what they do is they jump and they continue to run with the train for some time. In this running process, they lower their speed slowly and then eventually come to rest, right? So that they don't hurt themselves. It's the same as you're moving in a car, and if you suddenly apply a brake, there is a chance of you getting hurt, right? So what you do when you're driving a car, and if you want to slow down, if you want to come to a halt, you don't suddenly apply a brake. You keep decreasing the speed slowly, and then you come to a halt. Why? Same reason, because your body has a tendency of moving at that speed, so you have to reduce the speed and bring your body to that inertia where it can slowly come to rest. Okay, now that's about it. I think that's about it. No, one last important real life example is car airbags. Now when there is a sudden accident, what happens? Your car was moving at a speed and suddenly it comes to a stop. Now in that case, every passenger inside the car might crash into the windscreen or into the window glasses, and then there is a risk of harm, right? In that case, what happens? Your airbags come out, they inflate, and they give a cushion to the body, to the passenger, so that they don't crash, right? They give a cushion so that the inertia of the body to be in motion is stopped. Okay, so these are all the real life examples of Newton's first law of motion. I hope it was very clear. In the next class, we are going to discuss Newton's second law of motion and a very important concept, that is momentum. Okay, bache, keep learning, have fun. I'll see you in the next class. Thank you. Bye-bye.